Good evening, everyone. Hope you're having a fantastic start to your weekend, wherever you are. We're back. It's only been, a couple of years since we've done one of these. So let's see how long we can keep them up for this time. So I've got a brand new stack. So first of all, I haven't streamed for a long time, as many people like to remind me. Second of all, I've got a brand new streaming stack. This is a fresh VM. It's a fresh OBS setup because, God, I did not have my old one lying around anymore. So this could be a bumpy ride. So bear with me as we knock off the rust, and let me know if the text is too small. Let me know if the music's too loud. Let me know if I'm doing anything wrong, and we can do our best together to fix the plane while we're flying it. Hey. So I hope you've all been well. I know it's been, there's a lot going on right now, and full disclosure, there's a couple of keywords I've added to the banned words list in chat, just because there's some stuff going on in the world, in the media and whatnot, especially in Australia, that I kind of don't really feel like talking about tonight. And I know that some other people have expressed to me that they're kind of a bit over it all as well. So if you bump up against a banned word in chat, just consider that to be a bit of a hint that it's a bit of a bad vibes topic, and let's try to have some fun tonight and not worry about some of the horrible things that are going on around us right now. Barney serializing me, Fire and Civilized, good to have you all here this evening. Barney, how many password reveals will happen? I guess we'll have to wait and find out. Put your bets on now. You can place your bets on how many password spills I'm going to end up doing tonight. So what are we up to tonight? I thought we'd get things kicked off with something I did a lot of years ago now, actually, and I enjoyed it, and then I got distracted and never finished it. But while I was doing it, I was really enjoying it, and it's the Cryptopals series. So what it is a series of exercises that walk you through building various cryptographic primitives and usage of crypto. And then it walks you through breaking them, essentially. So it's good fun. I recommend you do it if you haven't already. Or stick around and watch me do it and fumble my way through it, either one. Let's have some fun with it, hey. Serializing, do I have a Mastodon? Yes, I do. You can jump on my Twitter. It's on there. I've got it. I registered it about a week ago now. Just because clearly Twitter's in a weird place right now. And Twitter's not one of the banned words in chat, by the way. You're welcome to talk about Twitter as much as you'd like, unless it gets annoying, in which case I'll add it to the banned list too. But I'm basically camping on a name on InfoSec Exchange, just in case we all have to make our way across there, which, as the days go by, it's looking more and more likely like we'll have to, right? So yeah, I'm on Mastodon. I'm not using it. I'm camping on my name, and it's looking like it's where we're all ending up, hey? Which, I don't know, I am certainly not an Elon Musk apologist, but as much of a dumpster fire as Twitter has been for years and years, it's the dumpster fire we've all come to know and love, and change is tricky, right? So yeah, serializing, that is me. I probably should set something up, like in terms of verification or validation, to show it's me, but it is linked to on my Twitter as well, so you can take that and me saying so right here as the fact that it's me. So Cryptopals, yeah, it's a series of exercises they go on to describe here that walk you through building and then breaking various poor usage of crypto. Apparently you don't need to know much math, you don't need to know any crypto. They want you to be able to code proficiently in any language. We're going to use Python because I don't feel like learning a new language on stream. Streaming's hard enough without it being a new language learning game. It's from Thomas, Sean, Alex, and Marcin. I don't know if I'm saying that correctly. And it's now being maintained by NCC Group. So kudos to them for a brilliant series. And let's just get underway, hey? It's broken up into 8 different sets. I don't remember how far I got through when I did it previously. So starting with the basics. They say that this is the qualifying set and it is intended to be relatively easy. So watch us get horribly, horribly stuck on it for a long time. And they say don't skip them, right? And They say that some of the exercises are important stepping stones to later attacks, which is something that I found to be true when I previously did it. And I previously found that I was reusing code from this set of challenges in future challenges. So we'll do our best to build everything in a modular way, in a reusable way. We'll try and push common code out to some sort of libraries file, and then in the exercises file we can pull from our toolkit that we've been building along the way. And I'll also do my best to write some tests as we go, so we can make sure that as we get to later stuff we're not breaking things too badly. So the first exercise, converting hex to base 64. So they give us a string here which looks like it's letters and numbers, hexadecimal, and they want us to produce this, which is apparently base 64. And they say we'll be using this code for the rest of the exercises, so hence we'll be jamming it in a library. So let's kick off our Cryptopals journey, and we'll create ourselves a virtual environment to put Python libraries in as we need them. And I'm sure a lot of people are going to be very disappointed in me, but since I streamed last, I've come across to the dark side and started using an IDE these days. I still use my Vim key bindings, but I've come to appreciate some of the nice things that IDEs give us. I'm still not great at driving one. We can perhaps use this series of challenges as a way to improve that. So we'll have to tell PyCharm to use our virtual environment. We'll use the existing environment. Cool, that looks good to me. And how are we going to break this down? So we've got set one, challenge one. So we'll do something like set one, challenge one, hex2 base 64.python. I'll probably regret that naming scheme, but we can fix it later. User bin env python 3. Let's grab all of this and chuck it in here. So we've got a copy. I love Java and Kotlin, so you want to use JetBrains. Cool. Okay, we found out that Barney's doing the get banned speedrun, so you're on track for a world record. keep it up. No, I do not love Java and I do not love Kotlin. I've come to appreciate Java more over the years. You'll still never catch me dead writing it, mostly because I don't know how, because I write in Python, because it's easy mode programming. We'll give ourselves a main function. No, that's not what I want. If name equals main, run main. So we want a hex to base 64 function, def hex to base 64, which apparently we're going to be reusing. It'll take an argument which we'll call what? Hex, which is a string, and it returns a string. And let's write some documentation and tests. Hex to base 64 over this. Should give us this. Let's just return empty string for now while we see how this works. So we've got a test written here. We right click on it, run the doc test. We get a failure, and we'll edit that doc test to test everything in the folder, Cryptopals, and hopefully it doesn't go and test everything in our virtual environment too. I guess we'll see, right? So if we run that test, it seemed to go pretty quickly. So it's probably not testing everything in the kitchen sink, but we'll see. We'll see how we go. And it's sometimes got a failure that it ran this, expected to get this, and got empty string. So now we fill in the details. So first thing we'll do is we'll translate the hex string into binary. So binary equals bytes dot from hex, from hex, give it the hex, and that gives us bytes. This is like one of the things I love about 90E is you hover over from hex, and it tells you it gives you bytes. Like, how good is that? Pretty good if you ask me. We then need to return that as base 64. So let's pull in base 64. And we'll return base 64.base 64 encode over the binary. And we have to decode that. I don't know why. This is what I don't get. Okay, Python's base 64 encode returns bytes. Like, I understand base 64 decode returning bytes because you're going to get binary garbage potentially. But why bytes for a base 64 string like that? That blows me away. The Wizzy says Control J should give me template for things like if name. Really? Learning stuff already. A new Python file, doot, Control J, shebang, user bin, and Python 3, Control J. The Wizzy, maybe my Vim key bindings are in the way of that hotkey. Perhaps. Cool trick, I might have to look into that later. Serializing. They want the developer to be the one to deal with the encodings. Right, but serializing, all good, Wizzy. But base 64 is always going to be alphanumeric and equalses and slashes and pluses and dashes and underscores, or whatever the set of characters that makes up base 64 is, right? Like, it's only ever going to be alphanum and a couple of symbols. Like, I totally get the case for base 64 decode being like, well, you might get null bytes or something. I don't know. If it represents UTF-8, you figure it out. But the encode is what blows me away. Anyway, so hex to base 64 is going to basically turn the hex into bytes, and then the bytes into base 64. If we run our tests are happy. Fantastic. So the challenge was to get this string and produce that. So we should be able to do print hex to base 64 over that. Instead of running the doc tests, run this file. That looks like it matches to me. Fine. You can provide alt chars where you're allowed to give any byte as part. Oh. Okay, yeah. Right, so you're saying that if we were to, I'm going to, let's do it here. Def foo return base 64.base 64 encode. Nope, b64 encode. Empty byte string. So alt chars is optional bytes. Yeah, okay, that makes sense. To support the alt chars. Cool. I'm happy with that explanation, so I'm going to go with that. Part 1 done. But what I'm going to do now is use a button that I don't normally use. Refactor. How do I move this to another file? Extract method? Nope. How do I move this to another file? Move. I'm just going to end up copy pasting this like an idiot anyway. Move the selected method to another package or class. Okay, let's move that to util.py. And away she goes. And from now we're going to pull from util, pull that in. This will still work. Cool. And if we go and run our tests again, our tests still pass. Now if we break stuff inside util, instead of returning that, let's again return empty string and rerun our tests. Close this file, focus ourselves on our challenge, run all the tests. Test breaks. Cool, so our testing is going to cover not just the challenge we've got open, but also our libraries or our utilities. Happy with that? What's the next challenge? Write a function that takes two equal length buffers and produces their XOR combination. So given this, after hex decoding and XORing against this should give this. Cool. This is fixed XOR. Set 1, challenge 2, fixed XOR. Okie doke. So now we're going to do our if name equals, because that's what I do. By the way, if you're unaware of why I'm doing this boilerplate for each file, if I was to run this file, s1c2 fixed xor.py by itself, this if condition, this branch will be taken, and main will get run, and all the fun stuff that this script is meant to do as a standalone, off it goes. But if on the other hand, this file was being imported, as though it was a library, just like we're doing here from util import this. When you import a file, the dunder name is not dunder main, so this doesn't run. So you can import it without running it, in case you've got some library in there you want to steal in some other piece of code. So we're going to create a function called fixed XOR. That's apparently what it's called. And it's going to take 2 hex buffers. I'm inclined to have this function take 2 bytes buffers and have the caller be responsible for byteifying the inputs. Because I'm just worried that this function, we might be kind of using it like not necessarily recursively, but we don't want a caller of this to have to do an unnecessary, I've already got bytes, now I've got to turn it into hex so that this function can unwrap it. So let's just take 2 different bytes arguments. So B1 is bytes and B2 is bytes. And they are also beloved cartoon characters. So our test, fixed XOR of this, keeping in mind, oh, hang on. That's not going to work because we've got to give it bytes, remember? So we're going to do bytes.fromHex over that. It's not going to want to indent for us. Let's keep this, let's just tidy this up a little bit. arg1 equals bytes.fromHex that, cool. arg2 is bytes.fromHex of this one. And then we do a fixed XOR of arg1 against arg2. We expect to get back. Again, like, I'm thinking this function probably serves us best if it returns bytes. So this would not be correct. We wouldn't expect to get back a hex string. We'd be expecting to get back the bytes behind that hex string. And I don't know that there is there an easy Python way to get from bytes to hex string, or do you have to do the wacky thing? Python bytes to hex. Like, I know old Python. Yeah, okay, you got to pull in another library, which is fine. Oh no, sweet. They've given it back to us. I know in Python 2 there was some way of doing it that was clean. This looks pretty clean too. So I'm happy with that. So let's do fixed XOR of that equals... no. Dot hex. There we go. So fixed XOR of that, and then you rehex it, and we get back this. So this here is just to account for the fact that the function takes bytes and gives bytes, which may end up being a bad idea. We'll see. So if we run the doc test, it's got a lot of complaints. That looks a bit better. No underscore in the from hex. Okay, one complaint I'm fine with. No, I'm not. Why did I have those equals there? So we're returning none. We should be returning bytes at the very least. We should return it, not just have it. Man, I can't even get a test to fail. It's not a good sign. Okay, it expected this and it got empty string. Cool. So fixed XOR of 2 bytes strings. First of all, let's just assert that length of B1 is the length of B2, because fixed XOR, kind of by definition up here, it takes 2 equal length buffers, so we'll just assert that to make sure early on it's happening. Args must be same length. And given that, we should be able to zip them together. So if we zip B1 and B2, for A, B in that, print A, B, let's just, instead of main, let's actually run this. Arg1 is that, Arg2 is that. I don't want the hex here for what I'm trying to do here. Let's just run through this so we can have a look at how zip works. We're running the wrong file. Barney, am I still freelancing? Yeah, somewhat. I've got a client. It's like a business-to-business contract arrangement, but at this stage I'm pretty well an employee. Feels like it at least. Let's print B1, print B2, and then do all this zipping garbage. Alright, so that's interesting, we've got some English text in one of the buffers. The first argument looks like this, 1C011100, the next one looks like English text. What zip does is it takes the first byte from the first argument and the first byte from the second argument and kind of puts them together. It's like you have the first one of each argument to zip. Then it's like have the second one of each, have the third one of each. Like we can see here that we had like 0100, there's our 1, there's our 0, and this right hand side here is each of the characters of the second argument to zip. So it's kind of like, it just gives off the first of each, then the second of each, then the third of each, and then we should be able to XOR those together, and away we go. Let's have our result is a list of bytes. For AB in zip, res.append. Oh, and by the way, when you take elements of bytes in Python, it gives you back integers. It doesn't give you back the byte, it gives you back the integer representing the byte. Same thing, I guess, but the type is int, not type of byte with length 1. So let's append to the results B1 XOR B2, right? Nope, A XOR B, because that's what we're pulling off of the zip. So now we've got a list of bytes, and we should be able to return. So we want to return bytes. Empty byte.join. Actually, you can just do bytes over the list. I think that should just smush it all together into bytes. So again, empty list, and then for each of the matching pairs, we append the XOR of them both. How did I do that? Can't even undo it. There we go. Yeah, we append the XOR of both and then just smash them all together. This, I think, should work. If we run the doc tests, all the tests pass, so this test is now passing. Main, if we run main, The result is that. Print the result. We get back the kid don't play. I mean, we were supposed to produce a hex string. So we print res.hex. That there looks like it matches that. Cool. Number 2 done. And I think this fixed XOR, which takes bytes and gives bytes, looks nice and well packaged up and reusable. So let's move that to our utilities. Building ourselves a nice little collection. Let's go on to challenge 3. Single-byte XOR cipher. Starting to get a bit dark here. I'm just going to quickly turn on a light. Be back in just 1 second. That's better. So, this hex string has been XOR'd against a single character. Find the key, decrypt the message. You can do it by hand, but write code to do it for you, please. And it suggests that we should... Okay, so I'm guessing we should probably brute force what that key character is, and then have the computer use character frequency type stuff to figure out which of the brute force outputs looks the most English-like. So that makes sense to me. Let's grab this. Don't know if that copied. Single-byte XOR cipher. Set 1, challenge 3, single-byte XOR cipher. Again, we've got main, does nothing, and then if the name. Cool. So we want break single XOR cipher, which should take, like, again, I just want to take bytes. I know it says the hex encoded string, but we'll take bytes. Cipher text is bytes, and it will return you know what, break single XOR cipher English, and then I'm comfortable returning string. I mean, this passage up here is telling us that we should score it and try to figure out which one's most English-like, so we should be assuming we get back textual data, not binary data. I think is a fair assumption for this type of challenge. And just to make that clear, we'll say that the function is it is for the English language, to make it clear that it's not breaking crypto over binary data. I may regret this, but anyway, no, I will return bytes. Just in case we're getting, you know, mostly English text, but with like control characters in it or something, like some unprintable character, let's safest to return bytes. We'll do that. So we'll return empty bytes, and let's document this. Use character frequency analysis to brute force single byte XOR cipher text. That'll do. Use character frequency analysis to brute force single byte XOR cipher. Yeah, that'll do. We don't know what we're going to get back from it. We don't have a good test case yet. We don't know what the plain text of this was. For I in, or for, let's go for K in range 256, which will give us everything up to 255 or OXFF, you know, all of our possible keys. Let's do the brute force. What are we going to do? let's go candidates is empty list. Candidates dot append. So what did we just write? We wrote fixed XOR. I kind of just want to write single byte XOR, which takes plain text, which is, again, we'll make it bytes, and key, which is int. And we'll assert that 0 is less than or equal to key, which is less than 256. Key is out of range. We'll return empty byte dot join b XOR key for b in plain text. Why can I not do that? Why can I not do that? Why is this yellow? Expected iterable union byte string memory view got generator of int. Actually, that's the wrong way to do it. Let's just do bytes over it. Okay, that seems good. So if we just write a test for this, single byte XOR over hex zeros with the key being OX41 should give us AAA. Alright, because a bunch of zeros XORed with 41 is going to be A's. Didn't like it. Source code string cannot contain null bytes. Oh, this is a doc test, so I've got to double backslash these bad boys. Cool. I'm okay with that. Okay, that test passes. Let's write another test to be sure. If we go a whole bunch of ones, actually no, a whole bunch of A's, XORed against 41 should give us our null bytes again, right? XOR is going to work the same way around. Yep. I'm happy with that. We've now got a function that's just going to do single byte XOR. I mean, we probably could have just inlined this where we need it, but it's in a function now. And if that proves to be a problem for performance, we can take it out later on and inline it ourselves. So to our candidates, for each of the 256 keys, we want to append from util import single byte XOR. We want to append the cipher, the XOR, single byte XOR over the ciphertext with the key being K, and then print candidates. Let's go new line dot join candidates. Let's grab this here. And do break single XOR cipher English over. Now that's a hex string. Bytes.from hex of that. Let's run our main. Expected string got bytes. Where's it angry? Didn't like this. Let's pretty print it. That doesn't look right to me. Oh, we're p-printing the ciphertext. No, it should be candidates we're p-printing. That'll be why we got that previous error too. Probably. Did I just replace ciphertext with ciphertext? I think I did. Candidates. Okay. So our 256 brute force attempts gave us all these as possible decryptions. Right. I'm guessing somewhere in here there's going to be English text. And we've got some things. We've got some cooking MCs like a pound of bacon. So that looks like our result we want. So our brute force looks sensible. We're getting back a whole haystack with a needle in it somewhere. Now we want our code to basically look through this list of possible decryptions and find the one that looks most English-like. And there's some things in here that look like they could almost be English, but we should be looking for the one that looks the most like English. Which, if we look at the briefing, we're told we can make jokes about ETAOIN, SHD, RDLU, which looks to me like the character frequency, most frequent characters in the English language. If we just Google it, Wikipedia, yeah, we get the history of it. Okay, I thought someone would have given us the frequency table just Googling that. English frequency list. We don't want the top 5,000 words. We want the English character frequency list. Wikipedia for letter frequency table. This is what I want. But I want it in a cleaner format, please and thank you. This looks pretty good. So we've got letters down the left, frequencies down the right. I'm guessing that the frequencies add up to 100, maybe? Can we grab this and clean it up somehow? Axiomatic, it looks like that exact string in the challenge, right? Are you talking about like this here, ETAOINSHSRHDLU? Because that's exactly where they get this from. It's the kind of classic reference to the most popular or the most frequent characters. Let's clean this up. Atari, holy shit, Christmas came early. Hey Justin, it did indeed. Fantastic to have you here. Let's keep working on cleaning this mess up. This works. No, let's do this. Hopefully this is not a tab or something awful in the middle here. It's a tab. Great. Okay, good. There's still an extra space here. Alrighty. En char frequencies equals this. It's not dumb if it works. Cool. Okay, so we've now got our list of English character frequencies. It's in a Python dictionary, which is unordered, kind of almost by definition. It tends to be ordered, but it's not really meant to be counted as being ordered. The list is in the order of frequencies, but more importantly, these frequencies here give the order as well. But not only just the order, but as per the name, the frequency of the character. So we should perhaps be able to use this to look at stuff like this and say, you know, does the number of E's, of which there's only one, is it the 12% of the characters? It won't be. But the sum of all of this, when looked over, all of this text is going to probably look more like English according to the frequencies than anything else in this list. That's the theory I'm going with here. And I'm sure that if anyone in the chat's done crypto before, they're looking at me fumbling my way through this going, that's not how you do it, or there's a quicker way. I'm sure there are better ways, undoubtedly. But let's go with this. I'm curious, do these numbers all add up to 100? If we print the sum of the frequencies dot values, do we get 100? Close enough. So yeah, I don't know if we're going to use it, but these numbers give us the percentage frequencies. All right, now I'm like the dog that caught the car. How do I want to use this frequency table to pick the best from our list of candidates? Do we just check to see if... Do we see... Okay, for each of these letters, E, do we check to see in each of these... Yeah, serializing. Do we check to see how many E's there are and then take that as a percentage of the whole string and be like, okay, it's 1%. Well, that's 11.02 off of this, so we kind of give it a penalty of 11.02. Whereas if 12% of this was E, it's like, okay, you get a penalty of 0.02. If 100% of these was E, we give it a penalty of 88-ish. And then we kind of see which one has the lowest score, like the lowest badness. Let's go with that. So let's scored candidates is a dictionary. For candidate in candidates, scored candidates of the candidate equals, what do we want to call this? Score English text by frequency of the candidate. And then from this dictionary we can then pick out the thing with the worst penalty or the best score. Yeah, so we've got to write this function now, score English text by frequency. And it takes in text, but it's going to be bytes. Yeah, this is... I'm sure a lot of people are screaming right now that text is not bytes, but oh well, and it returns an integer. For B in text, because it's going to be... because it's going to be a byte. B in text, keeping in mind when you iterate over bytes, you get integers. Oh, this is getting awful now, because we're assuming this could be bytes, we need to skip over anything that's not English text. Also, we've got to keep in mind here, these are uppers, and we've got to kind of do things case agnostically, so we've got to keep that in mind. Did I make a mistake by going bytes and forcing myself to deal with this problem here? Possibly. Let me have a think. Yeah, I feel like I messed up. Let's have this return. Let's have this return string. Actually, no. Let's not have it. No, because a lot of these aren't going to be English text anyway, so we do have to kind of account for that, right? I mean, and we could consider making that a penalty in and of itself. If something is not English text, it gets a penalty. Yeah, serializing of the characters. Well, serializing, I'm kind of wanting to account for the fact that you could have like hello world null byte be the site that's the plain text, right? I don't want to assume that the plain text is going to be mostly English, which we can score, but it could also have junk in it, like a null terminator or something. So I can't outright discard stuff that has characters outside the printable zone, but we probably should punish stuff that does have characters outside the printable zone. We should punish each character it has that's outside the printable zone. Otherwise, like something like, I'm sure there's one here somewhere that's like exclusively unprintable garbage. It would have a score of, or a badness of 0, which could be the least bad thing in the list. Probably would be the least bad thing in the list. What a mess. Okay, for B in text, printables is a list. No, I don't love it. I don't love it. What am I doing wrong here? How am I thinking about this wrongly? Give a score for how English-like text is. Text may contain punctuation and non-printable chars. Non-printable punctuation is not scored. Non-printable chars are penalized. That did not fill the paragraph like I wanted. That'll do. Non-printable char punishment equals, split the difference, 50. You get 50 points against you if you're a non-printable character, whereas punctuation gets no penalty. I think that sounds reasonable. Let's import string. We get some good stuff in there. Printables equals, let's map integer over string.printable. String.printable has some crazy stuff in it. So it's a string. It does have tab, new, return, OB and OC. That's not too bad. Cool. So printables is, and we're going to basically integerize them all, and we'll cast that map to, we'll realize that map into a list. For giggles, let's for giggles do some stuff. Let's have our main function not do this anymore, but instead print scoring hello world. null byte. And it needs to be bytes. So if we run main, something's unhappy somewhere. No, we don't want to map int across it. We want to map, because it's a string, we want to map ord over it. Yep, good. Printables. Okay, so now we've got all the integers, kind of character codes that relate to printable ASCII characters. Okay, now for B in text, if B not in printables, score minus equals the non-printable character punishment. So we'll start with score equals 0. We'll get rid of this print. So score equals 0 for byte in the text. If the byte is not in printables, we'll deduct from the score the non-printable character punishment. And then we're going to return the score at the end. So now if we rerun this, scoring English text by frequency over hello world with a null byte, we get a score of -50. If we get rid of that null byte, we get a score of 0. You know what? We should be doing these as... No, we should be doing them as... Yeah, we should add these as tests. Score English text by frequency of hello world. We currently expect to be getting 0. And then a single null byte, we expect to get a score of -50. Now, of course, this is going to change, so these are actually terrible tests. Let's run all of our doc tests. No, run the doc tests. There we go. Yeah, that was some very premature test cases. Anyway, so good. We've got our punishment for non-printables working. If B is in printables, then we should be able to do B. What should we be able to do over it to get it to a character? We should be able to just do chur over it. It feels gross churring a byte, but I mean this function's taking in bytes, assuming there's like ASCII, plain ASCII in the middle of it. Like Unicode's going to completely break this. We should be able to just chur it. C equals the chur of B, and furthermore, we should be able to upper it as well, which will then be able to be used to index into our list of frequencies. So now, no, for B in text. Why are we iterating over? Yeah. No, actually, we don't need to do this case right here, because now that we've, hang on. What am I doing? What am I doing? Iterating over text makes sense for punishing the non-printable characters, but it doesn't really make sense for doing the frequency analysis. For doing frequency analysis, we should be iterating over this. Yeah, we should. Okay. So now for C and expected frequency in English character frequencies dot enumerate, no, dot items. I think that's what we want. Print C and the expected frequency. The dot items should spin off key value, key value, key value. If we run our main, yeah, good. It's spitting off key value, key value, key value. Good. Okay. So for the character and how often we expect to see it, what are we doing? C upper equals C dot upper. So that way we can assume that our frequency table is uppercase, lowercase, doesn't really matter. C lower equals C dot lower. Count of C in text equals we want to ORed both of these to get the number. So now how do we, given these are both integers, count how often either of them appear in bytes? Text dot, do we get a count? We do get a count. What does it do? Return the number of non-overlapping occurrences of subsection sub in bytes B. Okay, so if we've got B hello world dot count the capital H's, we get 1. Count the L's, we get 3. Count the Z's, we get 0. Okay. This is just getting a bit gross. Can you look for like OX41? You can. So the hex of the chur of the H, no, the hex of the order of the H is OX48. So if we count for OX48, oh, we get 1. Okay, cool. So we can use dot count with an integer argument. Beautiful. So the count of C in text equals text dot count of C upper, which is an integer, plus text dot count of C lower, looking for either uppercase or lowercase. Frequency of C in text equals count of C in text divided by length of text, which we only need to calculate once. Length of text equals len of text, which, I mean, in cases of stuff like hello world with null bytes, the length is going to include these. So we're not bothering to only check how often the E's appear in the English part of it. We're checking the whole string, but YOLO. So now from the score, we want to subtract the absolute value of the expected frequency minus the frequency we've seen. We good? Again, if we run our main function, hello world null byte has a score of -200, whereas HZLLO world has a score of almost -190. Really? Is my logic really that bad that that is just as English as this is? Yeah, it probably is. Because it's so short. Fair enough. Fair enough. what if we just do hello versus ZZZZZ. The Z's are a little bit worse than the hello, but that's still not remarkably good. Have I messed something up? How's our logic here? Not great, is it? I mean, does it work? If we come back down to here, we've got, for candidate candidates, we're going to score the candidates. My mouse is going absolutely insane. Really? Okay, good. I feel like I've made a poor choice with this data structure. How do we get, why is my mouse doing this? Okay, seems fine now. How do we now pick out the candidate, the key with the lowest value? Sorted candidates equals sorted. I can't remember how to do it. Python sort dict. So here's what I was saying before. Dictionaries do preserve insertion order in Python 3.7 plus or recent Pythons, but it's an implementation detail, so I don't think it's guaranteed. So you shouldn't be counting on that. but the number one upvoted Stack Overflow is telling you to. Can you count on it these days? Should not be relied upon. This may change in the future. Update December 2017. Dict's retaining order is guaranteed for Python 3.7. From Guido. Guido says, Dict's keep insertion order is the ruling. I mean, are they promising to do that forever? What does the documentation say? I don't think it's promising anything in the documentation, but I mean, an email from Guido saying that dict keeps insertion order. That, I mean, if you can't trust that, what can you do? Okay, so here's how to sort dictionaries in Python, recent Pythons. Let's yoink that and use it. So the sorted candidates is key. Is this even going to help us? I don't know if it will. How can we use this code though? Return winner equals sorted scored candidates.items with the key being lambda x x1, so that'll get the value and use it as the key. Sorting is ascending, isn't it? And we want the biggest number, so we want the last item. Print winner. Let's watch this fail horribly. I mean, okay, it worked. What if we from pprint import pprint and then pprint the scored candidates? What did these scores look like? No. Yes. Sort of. YOLO. Okay, so like minus 1800, minus 1800, minus 1800, 500, 400, 400. 99. This one scored pretty well actually. What was our winner? It was close. 99.195. We want to print this out sorted. So pprint kv for kv in sorted candidates.item. What am I doing wrong here? No, scored candidates.items with the key being lambda x x1. That b should be a v. We run this. I must have misspotted something before. No, hang on. These aren't sorted. What am I doing wrong? Pprint kv. Why is this not sorted? Weird. You know what? Let's just go back to print winner. I don't love this solution. It works, and it's probably incorrect. I really don't like this. Feels bad. We expect to get back from that. I don't even know. What was it? I see that message in chat. Give me 1 second. It's sorted by key, not value. You need to sort. I thought I was sorting by value. Let me try again. We expect to get back this, right? Let's run our test, make sure it passes. It does not pass. Because I got my quotes wrong. I'm gonna get rid of these tests for this stupid scoring this whatever rubbish function. Alright, test pass. Cool. It's sorted by key, not value. You just sort per value. I thought I was, but let me try once more. Let me try once more to see just how bad this code is. So we want to pprint key value for key value in sorted scored candidates.items the key being lambda x, x1. x1 being value, which is exactly like what we're doing here as well. Does pprint not like, does pprint, maybe pprint doesn't like printing dictionaries in the order that new Pythons have promised to store them in. Like all these are, yeah, no, it's not sorted. What if we just print and go all the way to the end? Okay, so in this case we do get our cooking MCs like a pound of bacon right at the very end. I reckon pprint doesn't respect the fact that new Pythons commit to keeping order. Well, that's good to know. What if we pprint, but we don't dictionaryize it? Barney, can you start with the Rust statements? Yeah, go for your life, dude. KV for KV insorted. I mean, I've messed something up here. Let's just see what error I get. Okay, the highlights go away. Alright, this is what I wanted. Wow, all of these are really quite close in score. Like, it almost feels like luck that this one came out on top. But then again, it is very, very short text, so how much of a difference were we ever going to get anyway? Right? Right? Yeah, these are some very small numbers. And then these start to get really heavily penalized because they've got non-printable characters in them. So if like this garbage came out and then this came out and the needle in the haystack, the good plain text, had a non-printable character like a null byte somewhere in it, that would exclude it from the race. Like that would just put it way out into the untenable area. So I feel like we're getting lucky there. I feel like this scoring rubric is not very good. We may need to revisit it later on if it gives us issues. But in the meantime, go away. That seems to be working a treat. We're solving the challenge with that, aren't we? This hex string has been XORed against a single character. Find the key to crypt the message. Yep, good. Okay, we've satisfied that. Do we want to do we want to actually move any of these out to the utilities? I mean, as I said, I don't like this, but we probably should move it to the utilities in case it's useful later on. So we'll move our frequency table to utilities. We'll move the scoring function to utilities. And we'll move the breaking function to utilities. Alrighty, I'm going to take a quick 2-minute breather. I suggest you all get up, stretch your legs, grab a glass of water, stay hydrated, get yourself a paddle pop, whatever it is that you can do for a treat. And I'll see you on the other side of this very short break. Alrighty, we are back. I've turned off the Monster Cat bot in the chat, by the way. Turns out you're all being real shy, real quiet tonight. So Monster Cat was talking to itself and filling up chat. If you want to know what song's currently playing, you can do Bang's song in chat, I think. It'll then pipe up. Otherwise, yeah, music tonight is by Monster Cat. Check out, they're a label. They've got a bunch of great artists. Check them out for sure. But yeah, for now the bot will be a lot less chatty. Let's go to the next challenge, hey? Challenge 4. Yeah, again, like they say that most of these challenges take like a couple of minutes. That one did not take a couple of minutes, but anyway, we'll keep going. What are we on? We're on number 4? What are we up to? Yeah, number 4. Detect single-byte XOR. One of the 60 character strings in this file has been encrypted by single character XOR. Find it. Alrighty. A whole bunch of nonsense. Cool. This might stress our bad English frequency code. We might need to rewrite it sooner than we thought. So this is set1 challenge 4.text. Drop that in there. And let's go set1 challenge 4.py. No. What is this challenge called? Detect single char XOR. What are we going to need from utility? Import. What is a utility? We probably want scoring English text and breaking single XOR cipher. So we want break and score. Def main does nothing. If the name is done to main, run our main. Grab the text. Cool. So main with open s1c4.text. It's f. Candidates equals f.readlines, I think. Does that give me what I want? Okay, so they all have new line on the end. That's kind of gross. X.strip for X in. That's kind of gross as well, but it'll do. Yeah, that chops off our new lines. Cool. So we've got all of our candidates. So now we'll create a function. What is it going to be? Find single char XOR ciphertext from candidates. And candidates is a list of probably want list of bytes. Let's pull in that list, and we want to return again. We want to return bytes. So it'll return the lucky plain text from the list. Return nothing for now. So now these candidates we need to actually bytes.from hex them. There we go. So now we're getting our bytes. So candidates is now list of bytes. Well, yeah, list of bytes. And we want to print find single char XOR ciphertext from candidates over the candidates. And that will ideally give us the lucky plain text from the haystack. Cool. So this function here, find single char XOR ciphertext from candidates. I'm overusing this word candidates now, because what I want to do, C2, candidates 2, I might think of a better name for that in a moment. C2 equals the list of break single XOR cipher assuming English over the candidate for candidate in candidates. Yeah, I don't love this candidate C2. What if this is the haystack? And then this here is the candidates. And then this candidate here is B, YOLO. So we're going to break over the bytes for each of the bytes in the haystack, and we're going to have our candidates, which will be a list of, so for each thing in this list, it's going to brute force with all the keys, find the most English-like thing in that list, and return it. So this here is the list of, assuming each of these was single-byte XOR cipher texts, the best guess decryption of it. And I'm guessing not all of these are actually single-byte XOR cipher texts. For any of them that are not single-byte XOR cipher texts, we're going to get back rubbish. We're going to get back the most English-like rubbish of the possible brute forcings of it, but it's going to be rubbish. But one of them will be English, hopefully. So if we print our candidates, we'll pull in pprint. Is there English in this list? I bet there's not going to be. I mean, I shouldn't be disappointed. I just said there probably isn't going to be. No, there's no English in that list. Barney, no, I did not go to B-Sides Melbourne this year. I haven't been to conferences for a long time. I think this means we need to fix our scoring algorithm. Do we have a test written for this challenge? No. Oh wait, maybe we do. Do we have a test written for this function? Yes, we do. Okay, good. So I think we need to... Why is this yellow? Expected bytes got int. Really? I think PyCharm's a bit confused about the types here, because that's not int, it is bytes. Yeah, weird. I think we need to fix this function here, hopefully in a way that doesn't break this one, but causes this to start working. I think we've got a problem with our scoring of English text by frequency function. Let me have a think about what we can do here. Is it time to just start Googling and seeing if there's a non-stupid way of doing this? Score English text frequency. Developing algorithm for detecting plain text via frequency. This sounds good. Okay, so what is their proposal? I'm currently attempting Matasano. I think the Matasano crypto challenges is Cryptopals. So this here is someone doing the same challenges as us. That feels a bit too much like cheating to read their post. Let's go for a different one. Frequency analysis of a substitution cipher using base 64. I don't think this is relevant to us. Character frequency graph, not for us. Character frequency scoring operation. This sounds good. Okay, again, we've got someone doing Cryptopals. It feels like cheating to read that. Probably shouldn't feel like cheating. We are looking for someone who has solved the problem we're facing. Can we work this out? What is the non-silly way to be scoring potential English text to see how English it looks? I'm just going to create a little dummy function here called play. Can we run that? Nope. Here's our new challenge. Let's just put it in there. Now let's just print that. And let's run this. Okay, so that's exercising the function. So now we can maybe just sprinkle in some little debug by print. I realize I'm in a debugger and I could use the debugger, but let's not. At Wolf, my method was just going to loop over each result, decrypt, and then look up each character in the frequency table and then add it together. Yeah, at Wolf, I'm not sure how you were thinking of adding it together, but like that's the part I'm at as well. It's like I've got the table, I've got a candidate decryption, but what should be the logic of scoring? I'm not sure exactly what you meant by add it together. Maybe you hadn't cracked that nut yourself just yet, but it's the tricky part, right? Like what are you adding or subtracting to arrive at a score? So score English text by frequency. Let's just cheat here and go print text score. Put in a tuple. So now if we run this, oh no, again, I kind of liked the sorted view we had before. How did we do that? It was here, wasn't it? So we want to print. We want to import pprint, and then we want to pprint kv for kv in sorted scored candidates.items with the key function being lambda x x1. That rings a bell. And it doesn't like it. Pprint's not callable. From pprint, import pprint. Alright. It's no longer yelling at us. Still yelling at us down here, but I think PyCharm's wrong there. I mean, it doesn't help that my code sucks. I'm not saying PyCharm shouldn't be wrong, but yeah, my code sucks. So now we get a generator. Thanks, I hate it. Let's actually realize this into a list. There we go. So yeah, we've got cooking MCs like a pound of bacon, and then we've got this stuff here. It's all suspiciously close. Now we've got a bit of debugging output. To do remove me. how do we fix this function? I mean, I don't hate this punishment function. It could break, but I mean, I think the challenges are kind of like happy path challenges where like the result we're looking for does have 0 non-printable characters in it. If we came up with some scoring rubric that like didn't punish text for having characteristics, but instead rewarded it for certain characteristics, we could probably get rid of this, because if it's all unprintable, it just won't get any rewards. But we need this in place while we've got this kind of punishment methodology in use. By the way, @Wolf, good to see you here. Hope you've been. It's been a long time since I've seen you. Yeah, hope you've been well. How can we reward well-formed text? Is there a way? Are we being too fancy by trying to use the specific frequency? Should we simply be using the order of the letters? Would that be more reasonable for some reason? Because like a lot of text is going to get hurt for having no Z's, J's, or Q's because they're just very infrequent characters. But then they're all going to get hurt equally, right? All right, on @Wolf. Cool. I'll have to catch you on OJ's Discord. Glad to see you. You found your way here. Like, what if we just took text and sorted its printable characters by frequency, and then compared that to like, are they at least in the right order? No, I still don't love that. I think using these frequencies is the best shot we've got, even though it's somewhat noisy because a lot of stuff just won't have any, especially short texts, just will get annihilated on some of these. Are we just doing something stupid here somewhere? Like, this logic here sounds reasonable to me. If we're going with the do punishment model, do we have a problem here somewhere? It's all checking out. We subtract from the score the absolute value of the expected frequency minus the frequency we've seen. Like, so it looks like, I mean, for what I wanted it to be doing, it's doing it correctly, I think. If it's English text, don't have 3 of the same letters in a row, you can discard all of them. Yeah, that's true. But we are talking single-byte XOR here. After trying to brute force single-byte XOR, you won't ever have 3 of the same letters in a row if the ciphertext didn't have 3 of the same byte in a row. If the ciphertext does have 3 of the same byte in a row, every candidate that gets pooped out the other end is going to have 3 of the same letters in a row, kind of by definition of single-byte XOR, right? So I love the theory, but it will either do nothing or throw everything away for us, right? So I don't think that works here. All of these are just so close together. Do we have to, I don't know, I don't do math, but do we have to use like the log of something so that like if something's close enough, it gets punished a lot less comparatively than it being like really far away? Like if it's 1 off, it gets a little bit of punishment. If it's 2 off, it gets more than 2 times the amount of punishment. Like, does using the log of something feel like it's going to help us? How do logs work even? From math dot log. What is a logarithm? Return the logarithm of x to the given base, and the default base is e. So math.log of 4, log of 5. 1 versus 2 versus 3. I mean, does this like smooth something out for us somehow? Probably not. What's the log of 0? It's okay. If something was like bang on the money, then it's going to like break anyway. That's probably a sign that it's not the right thing to be doing. Alright, I'm over it. I'm going to go read Stack Overflow. Or Crypto Overflow. Crypto.stack exchange. What is the correct way to be doing this? What was this poor soul's original attempt? Probably much better than ours. Oh, math.log. I mean, okay. Maybe it wasn't stupid. If C is greater than 65, so if it's, I think this is like lowercase and this is uppercase, or maybe the other way around. Turn negative sum over math. Okay, this is looking kind of a little bit wild, actually. Evaluate the frequency in the candidate plain text and compare that against the expected value, which is what we're doing. Penalize the score. Okay, this is similar to what we're doing. We're talking penalizing the score, multiplying it by 1 minus the standard deviation cumulative probability. Okay, this is actually probably quite genius then. There's 1 standard deviation away from expected, multiply the score by 1 minus 0.68. 3 standard deviations, you multiply by 1 minus 0.997. Add the cumulative score for each value the most. Okay. Is there a better established algorithm out there for performing frequency analysis? Perfect question. I would love to know the answer. Is it simply the nature of short cipher plain text that there will be inherent inaccuracy? I think there will be. But I was very disturbed by seeing so many being so close to the money here. But yeah, it is a tough arena to be playing in, I think. Okay. It's better to first calculate the frequency of each letter in the decrypted message, and then compare the frequency distribution to what would be expected for English text. For comparison, you can use chi-squared testing. I wasn't going to think of that myself. Good. Okay, checking the solution was the right idea. For comparing the likelihoods of different decryptions, you don't even need the complete list. Start by comparing the actual observed number of occurrences of each character C in the decrypted message with the expected number of occurrences of that character in a piece of English text of the same length, and calculate the test statistic. Math, great, i.e. the sum of the squared differences between the observed and the expected frequency divided by the expected frequency. Okay, so chi squared I've never worked with or heard of before, but looks like it's the way to be going. Sort the decryptions by chi squared in increasing order and print out the first few. If you wish to estimate the actual likelihood of the message being English, determine the number of degrees of freedom K for the model. This is getting kind of wild now. Is there an easier one? I'm not going to try and pronounce that. The B coefficient is an approximate measurement of the amount of overlap between two statistical samples. Okay, sounds good. If you have the English letter frequency, you can calculate the letter's frequency of your nominated plain text and then calculate the BC. When comparing plain texts decrypted using different keys, this method can be helpful. The one that most likely makes sense. Okay. I tried chi squared and BC. I found it to be much more robust without requiring any hacks for ignored or unprintable characters. Okay, I dig that. It naturally lowers the score for text with invalid characters. I dig that. It's more performant. Cool. The accepted answer is correct, but I wanted to add an update. Okay, this is complaining about the chi squared stuff, but is the underlying cause the fact that Matasano or Cryptopals don't align with regular English frequencies? Oh yeah, because we're missing the character frequency. Okay, yep, that makes sense. Hopefully we can just YOLO with the frequencies we've already got. Otherwise, do we get frequencies here? Yes, but it's a bit of a mess. Okay. So what is this coefficient? At Wolf, maths is hard indeed. It's hard. And I was promised something by Cryptopals. How much math do I need? If you have any trouble with the math in these problems, you should be able to find a local 9th grader to help you out. Bullshit. I'm looking at stuff like this, and I'm not knowing any 9th graders that can tell me how this works. So, yeah, no, I'm calling BS. Alright, this is looking nasty as well. Maybe this is the end of the road for me, because I'm not going to have any luck. Oh, the 2 multivariate normal distributions. Perfect. Thanks, I hate it. Alright, where's the stupid people answers? What about scoring? Please do tell. So this here has not actually got any scoring implemented, so that's not helping us. Okay, We don't have any we don't have any concrete advice on how to do the scoring here. Are we going to be stuck doing like this? This here, I'm thinking, looks more difficult than the chi-squared description. Chi-square. Okay, I'm going to just take a minute to read this. Let's see if it looks any more usable. This is not looking any better. Barney, no. No, you. You use Yahoo instead of Google. Let me know if you find something. So we should expect the number of white-collar workers in neighborhood A to be 150, so the population of A multiplied by 349 over 650. So the 650 comes from here. Where's the 349 coming from? Is 349 the sum of this? I want to say so, because 5 and 4 are 9. So we get 150, 254... 349, yep. So, because it's expected that white collar workers is going to be the sum of that first row divided by that. Yeah, so we do expect 150 times that, 80.54 white collar workers. Okay. This is making sense so far. Let's see if it holds up. In that cell at the table, we have observed minus expected squared over expected, which is, so we got 90. And we expected 80.54, and this 80.54 basically runs down here. No, if we take that and multiply it by the length of the text, then we would get that. Yep. So observed minus expected squared over expected is 1.11. The sum of these quantities over all the cells is the test statistic. Under the null hypothesis, which I still don't understand what that is. This sum has a... Oh, it hurts. It hurts. Alright, I kind of followed... I followed that. This lost me. The sum of these quantities over all the cells, is that like all of the 3x4 is the test statistic. Okay. Do we just like slap in observed minus expected squared over expected? And use this, observed minus expected squared over expected. Does this number get bigger Like, okay, so if observed minus, if it was like bang on the money, this would be 0. 0 squared over expected. 0 over anything will be 0. So if it's good, it's a small number. If it's bad, it's a big number. If we observed 0 and expected 100, 100 squared over 100, it's a big number. So I think this number still gets bigger the worse off it is. So we just like slap this in and cross our fingers. Like, is it just a better score minus equals, instead of taking the absolute of this, do we do that squared divided by the expected? And this should be observed minus expected. Not that I think it makes a difference, but we'll just... Oh, come on. Observed minus expected all squared over expected. Does this just like magically work better? I mean, we get the same result. It doesn't look like it. No, it didn't like make our solution that much more different from the pack. So what can we still use this though? Do we need to actually calculate numbers of degrees of freedom or something? Number of rows minus 1 multiplied by the number of columns minus 1. 6. Okay, in cryptanalysis, the chi-squared test is used to compare the distribution of plain text and possibly decrypted ciphertext. Okay, what is this saying? I mean, is this what we're doing? Thanks, I hate it. My mouse is being whack in this VM. Oh, hang on. Hang on. This is talking about population. What numbers am I working with? I'm working with frequency. That's not quite the same. Okay, let's just YOLO comment that out. Okay. Expected, not expected frequency, but expected count equals... Okay, so I used to be getting the count, and then I was establishing the frequency by dividing by the length. Okay, so expected count equals expected frequency times the length of the text. Observed count equals this. So we subtract from the score. No, I lost what I was doing before. How does chi-squared work? Observed minus expected squared minus, no, divided by the expected. That's more faithful to this example using populations. We're no longer subtracting frequencies, we're subtracting expected and observed counts. Does this make things better somehow? I mean, yeah, I think that's a bigger difference, relatively speaking, than the differences we used to get. Maybe we good. Let's just comment this out because we might need it again shortly. Can we run our detect again? No, not it. Yes. Yes. Just going to comment this out in case we need it again. We rerun. Not what I wanted. Oh no, it is what I wanted. Now we search through the haystack to see if there's English in here. There is not. I didn't see any in there. What's that? Now that the party is jumping. The fact that I had to scroll through that twice makes me... Well, I did scroll through it twice previously, right? Maybe? Let me back out the change I just made and see if we actually had it all along with our previous bad code. Glad I kept that. So if we just get rid of that, bring this back, and rerun this, was jumping in here all along. Can I find? No, can't find. You know what? We can use a computer to do this for us. Now we know that jumping appears in it. Let's go back to the new way of working. Let's do res equals that. For r in res, if jumping in r, print r. So under the new way of working, what's going on? Oh, I'm p-printing candidates here. Ah, sorry. Dark Mesa, it's been a while since you last streamed. I can't watch the stream now. Could you kindly keep the VOD? It'll be on YouTube. So the VOD won't be on Twitch. But once I have kind of cut it up, sliced it, diced it, and gotten rid of the BRB slides, that will be on YouTube in the coming days. So Dark Mesa, yeah. Don't be disappointed when it won't be on my Twitch. Maybe one of the panels down below makes that clear. If it doesn't, I'll fix that. But definitely check out YouTube. It'll be on there. Thanks for dropping in. Really good to have you here. Hopefully next time I can do it at a better time for you. He says as though there's going to be a next time. We all know there won't. Thank you. Yeah, my pleasure. My absolute pleasure. So now for C in candidates, if jumping, are these all bytes? Yeah, they're all bytes. If B jumping in C, print C. That's what we want. So if we run this, okay, so we do get now the party is jumping. Yeah, right. Well, that's still a next time. Okay, so now let's back out the change we made and see if we actually had this solved the whole time. I just didn't see it in the list. Okay, jumping was never there in the first place, so we had to make the change with the chi square, which I'm probably misusing, for it to pop off for us. Lana, so good to have you here, my friend. Welcome. Okay, so what have we got? Candidates equals, we're going to just do the break across everything in the haystack. So now, we basically want to repeat the same thing that we've been doing in here. Scored candidates. For candidates, we'll score them and then get a winner, which I'm just going to steal this awful code. And hopefully it pops out with jumping being the best of the bunch of bests, if that makes sense. So scored candidates is dictionary. For candidates, score them. We don't want this peeper in here. Winner is the best of the bunch, and return it. And again, PyCharm hates me. Fair. So now, main. So we're going to read in our candidates, and we're going to get res. Let's just print this. Let's just print find single-byte XOR ciphertext from candidates over candidates. See how we go. Run that, and we should get jumping. And we don't. Yes. There's something in that mess that looks better than jumping. Fantastic. All right then. Let's bring back the debugging code that I very hastily deleted because I was sure this was going to work, and find out what our candidates looked like. God damn it. Okay, so now the party's jumping was the second best. By quite a lot. So this has a lot of unprintables. The unprintables. We were using 50 as a punishment for each unprintable. We're now getting these astronomically large numbers thanks to chi squared just like blowing things right out of the water. So we're not being punishing enough against bad characters. What did Stack Overflow tell us we should do with bad characters? Do we need to do this degrees of freedom? And then integrate. I don't wanna. Okay. How do we punish unprint? How many unprintable characters are there in here? 1. What's that? Oh, okay, that's just because there's a single quote here. So we got 1 unprintable, 2, 3, 4, 5. It's not a huge amount, but we're really not being that mean about them. I mean, of all the text we're decrypting so far, everything is like pure printable. Even though this has a new line at the end. Like we could just throw away anything that's got any unprintables in it. But that feels like it's kind of cheating because like pretty much all these would just disappear, and the frequency analysis probably wouldn't have been important at all, and it feels like we should treat that as important. So how do we need to punish stuff? What did other people say? Is it this? It's nice to have the frequency of the space character. Do we want to find a better frequency table that takes space into account? I think we do. I think we want a better frequency table. English crypto frequency table. So this one didn't have space. No, didn't have space. Crypto corner. English letter frequencies from practical cryptography. So we don't have space in here. So we've got bigrams and trigrams, which I know are, getting fancy. This doesn't seem to have space either. Including space. We could just crib the one from Stack Overflow. That's another thing we could do. Actually, you know what? I probably should have cited. No, that's not what I was using. I was using this. I probably should have actually given that credit here. That feels like the right thing to do. Frequencies of letters, frequencies of letters, frequencies of bigrams with space. We don't want bigrams, but that's looking like. Ngrams, books, datasets, v2. What is this? Ngram viewer. 1 grams. I think that's all we want. Why are you giving me gzip files? Why are these gzip files? I just want a frequency table. I just want milk that tastes like real milk. I mean, okay, so the fact that no one on the internet apart from this person on Stack Overflow is talking about frequency tables with space in it might mean that it's not really a done thing. None of these tables have it. This person has kindly given one with space in it. Apparently space appears 19.18% of the time. We could just like sneak that into our table and have it add up to more than 100. What's the worst that could happen, right? Or is there some other way to reward space? We probably shouldn't jam it in the table. We should probably reward space. At Wolf. Yeah, true. The frequency tables probably are built on... Well... I mean, yeah, you could write a frequency table for the dictionary, but I would think a frequency table for literature becomes more worthwhile because the dictionary won't really help you account for the fact that the word "the" appears a hell of a lot in literature, right? Whereas if you built your frequency tables from English literature, I would have felt it would be more useful. If I was building a frequency table, I would do it from literature, put it that way. The frequency tables are built on top of ngrams. Okay, so that's starting to sound pretty smart. I would say so. I'd say that's right. How about we just add another iteration to this? Like we'll hack it in here, and let's say we expect, according to this person, 19.1% of the text should be space. Like we'll leave this scoring the same, and we'll just kind of like put in some stuff to do with spaces just for a treat. It's an awful hack. Assuming they appear 19.1% of the time. And let's just grab this. Come on. Great. Now I can't scroll in my browser or click in it or do anything in this VM. I'm going to take a 5-minute break to fix my VM. And I suggest you all, as I said before, get up, stretch your legs, get some water, grab yourself a paddle pop, do what you need to do, and wish me luck in fixing this VM, because I think I'm going to need it, and I'll see you on the other side. Alright, it came back to life with some angry messages on my wall from syslog, and yeah, this machine's actually pretty laggy. And I've just realized that my IDE is using half the RAM for this VM, and it's got 8 gigs. So that's a hungry editor. This VM feels a little bit sick, so I might need to do some work on it before next stream, which at Wolf, I've got a year or two to do it, right? So no harm done. At least it's come back to life for now. Let's see if we can have it hobble along till the end of the stream. As I said, let's give this post some credit in our code. Copy. Just for a treat. Okay. Yeah, this machine is not well at all. Expected count spaces equals text.count. Talking bytes here, which is weird. I call it text, but you make bad decisions sometimes and you live with them. No, that's not the expected, that's the observed count of spaces. Expected count of spaces equals 0.191 of the length of text. And then we do the cheese squared trick. I'm really sorry, I did see before someone mentioned in chat. Yeah, sorry, I did see this SCOGs from SciPilot.stats import cheese square. I saw that, but then I forgot to come back to it. I'm curious now, actually. I am curious. SciPy.stats cheese square. What does it do? Frequency observed, frequency expected, something, something. Let's look at the source. Were we close enough? The power divergence. Oh, yes. Yes, the power divergence of the frequency observed versus the frequency expected. Thanks, I hate it. What is a power divergence? And GitHub doesn't want to go to the code for me. Anyway, I think we're doing well enough. So score minus equals the observed count of the spaces minus the expected count of the spaces squared divided by the expected frequency. That's a bug. That should be expected count, right? Am I wrong? Chi squared test. Yeah, we're talking occurrences, not frequencies. That's an awful bug. That should be expected count. Let's comment this out and see if that fixes things. Yeah, that makes sense why those numbers were so freaking big, because we were dividing by like fractions. Like in the... Oh no, we weren't.
It was at this moment that he knew. He fucked up.
I fucked up real bad. I was thinking these were percentages like 0.12, 0.09, 0.08. I was like YOLO multiplying stuff by... Oh god. Oh no. Count of C in text. This is my old code. I was counting stuff. I was establishing the frequency, which was the count, divided by the length, which is always going to be like less than 1. And then I was calculating its distance from the number fucking 12. I thought that was like 0.12. Fucked up real bad. Okay, this should never have worked. Maybe if we fixed that, it would be comparable to the chi squared. But we're already YOLOing the chi squared, so let's keep YOLOing that. Wow. Oh, that's awesome. Okay, so I fixed this. Does that just fix our problem with the jumping? First of all, do all our tests still work? The doc tests, run them. Tests are still happy. I think that means like this challenge here still works. Cooking MCs like a pound of bacon. Yep, good. So we didn't break that with fixing that bug. So now we've got challenge 4. And I'm no longer doing the stuff with the hack with the spaces for a treat. This code's becoming a mess. I'll have to clean it up later. Does this work? Okay, good. I think this is just debugging noise. Let me get rid of that so we can revel in a clean, correct answer. Where is that printing happening? Here? We got it. That was way harder than it should have been. Oh no, that's terrible. Okay. Brilliant. Yeah, that should never have worked. But we got there in the end. And we got there in the end without having to do the trick with the spaces either. You know what? To do, consider rewarding spaces per... There we go. Let's just get rid of this code to clean stuff up. I'm just going to delete this because we're no longer using it. We're using chi squared. Whether it's better or not, I don't know, but it's working. And this also has a terrible bug in it, so I'm just going to get rid of that so it can't hurt anyone again. Right, now, this challenge here, I'll leave the debug code in there because yeah, we've proven to need it more than once. Test case. So that when we undoubtedly change that scoring method again, we can check to see if this breaks, right? So this here, actually we need this as well. Yuck. Should be fine. It's kind of gross to have tests with the file in the PW anyway. If we run our tests, does this yell at us? Oh, a lot of stuff yells at us. How do you write tests with like indented whatever? How do you write doc tests like we... YOLO. Let's be ugly. Candidates equals bytes.from hex XOR strip for x in f dot, I don't know, open text file dot read dot split on new lines. Actually, can we just do read lines? Does that make the test happy? Yep, good. Here's our solution. Now we run our tests. Oh, what now? Oh, it doesn't like the backslash. Drop a slashy boy in front. Cool. Okay, all of our tests run clean now. So this means, again, yeah, as we undoubtedly go in and fiddle with our previous code in future exercises, our tests, which are now getting kind of slow, our tests will make sure we're not breaking previous use of that same code. Alrighty. Do we have time for the next challenge? Number 5. Implement repeating key XOR. Encrypt it under the key ICE using repeating key XOR. Yeah, so like you kind of wrap and loop this and then do your XOR against that. I'm confident we can get this done, but perhaps if we're not going to be able to do the one after it, which probably uses this, we should save this to give us something easy to get started on next time, and then we can maintain flow throughout the next stream. Let's see what challenge is coming up after this. Break repeating key. Oh yeah, no, I know that this is kind of a little bit gnarly. I got to get something to eat, and I'm not going to be able to make my way through this evening. So we'll call it for now. And I honestly do plan, well, once I get this VM fixed, I do plan to do more of these more often. I've had a lot of fun tonight, and a few close friends recently have said I should do it again, so I would love to be doing that more often. What do we have? Yeah, my brain just broke. That's what I was going to say. I'm not going to have a schedule for now. I'm not going to commit to, precise days like I used to. It's going to be kind of as I can, and as I'm able to. And the other thing is I will have like a pretty decent shutdown over Christmas. I'll be traveling for the holiday period, and I won't have my streaming rig with me. So no streams over Christmas, but hopefully we'll get a few in before I head off. And then in the new year, we will see how we go. See how long we can maintain this for this time. But thank you everyone for showing up. It was so good to have you here. Thanks for your help and for your assistance throughout the evening and your patience as we muddled our way through some stuff that it's one of those things where you think to yourself after you've done it, like, that shouldn't have been that hard. That bug should never have existed. But that's the rub, especially when you're doing stuff live on stream, you're talking things through. I'm just making excuses now, but hey, this stuff's tricky, so there you go. Thanks for turning up, Barney, @Wolf, Alana, Serializing. It's so good to have you all here, and I will catch you on the next one.